Hello, my name is Paulo Jr. I'm from Brazil and I work in Conprove. Today I will present the technical paper Performance Assessment of a Line Protection Implemented with Process Bus and GOOSE through Transient Closed Loop Tests. First of all, this is our friend John. John knows everything about hardwiring. But when John looks at this condition, he is afraid of communication network, Ethernet, and optical fibers. And now about our work, we have to say it's an experience of 87L protection using the process bus. They were performed in a closed loop tool with operation characteristics equivalent of the real-time simulators, enabling the dynamic tests of the protection. The performance of the traditional hardwiring system was compared with the IC61850 environment with hundreds of cases. The IC61850 is already a reality. The client server MMS and GOOSE is already stabilized in using in utilities all over the world. The process bus is the next challenge. The IC61850 have a lot of advantages: the standardization, the security, the economy, and the simplicity of the cables. The modern IEDs, the protection relays, now have new communication features and protection algorithms. To do tests on it, we have to evaluate our tests to a dynamic test to perform tests with transient conditions. We need to do a closed loop test to verify with a depth of condition the response of the IED. And to do this kind of tests, we can use an iterative method instead of a real-time closed loop. What's the difference? To test device like a voltage or a speed regulators, we need to do this in real-time condition. Why? Because our virtual environment and the system was modeling inside our simulator. We will inject the analog outputs like terminal voltage, current in the voltage and speed regulator, and the answer of the device under test will be mechanical or field voltage. And this condition will be used inside the simulator, and again the output will be changed in each time step. This condition is an analog signal. These signals change all the time and have to be done the tests in a real-time condition. But when we test a device that is a protection device, protection ID, it's a different condition. We have the modeling in a math in the simulator. It's a virtual model, and it injects the voltage and current, and the answer of the protection ID in this case is just digital answer. It's just Boolean, or 0 or 1, and did not change all over the time in each time step. With this condition, we can do a closed loop with an iterative method. About the testing tool. On the testing tool, we can model all our components. Our equivalent, our circuit breaker, our voltage transformer, our current transformer, our line with a lot of parameters with frequency dependent, Bergeron, and other. And the signals was injected on IEDs with analog signals from the CT or VTs. The tool can simulate too the digital signals from the circuit breaker, the status, and can read from the IEDs with the testing tool inputs the response, the answer that IED will control the circuit breaker to make it open or make it close in a recloser. All these conditions can be changed to the IC61850 with GOOSE and sample value signals. How the interactive method works. First, will be simulated the signals with a pre-fault and then a fault. This is injected on the IED under test. And the response of the IED here, like command the circuit breaker to open here, this answer will be put inside of the new simulator. And the next step, the new simulator will be changed from the first one, because now we have the circuit breaker opening with the modeling, with the time that is inside of the modeling. And then the last one, it's injected the last waveform and the answer of the IED opening the circuit breaker, and here it's going down because the current is not present anymore. And that the last injected signal is the same of a real-time simulator. The case study. We study in two environments, the conventional one with hardwire and the second one with IC61850 will be 500 kV 87L line protection, will be 260 cases divided in 10 traditional groups. This is the diagram of protection line, circuit breaker, CT, and the other side, circuit breaker, CTs, and everything. The methodologies. In the first one, we have the hardwire. The test set will inject the currents and get the contacts of both relays. On the IC61850, we have a switch, and all the signals goes through the switch, the sample value and GOOSE signals. And the 10 groups of tests. The first one will be 50 tests with internal faults, changing the location point. Then 50 more cases with involving internal faults, change the type of fault with phase ground to phase ground. Then an internal fault, changing the resistance of the fault. Then external fault to verify if the function must not be tripped. Then external fault that after 6 cycles will be an internal fault. Then other external fault, varying the burden, the resistance of the CT to verify saturation and the response of light and heavy saturation. And then external fault following by internal fault, verifying to the saturation of the CTs. Then we'll perform the SOTF in both terminals. And then with change frequency to verify the response. And test without the communication. We have here one kind of test to verify the behavior, and the repeatability will be test 20 times. The case here we'll choose it's phase out to ground, 0% with incident angle of 0 degrees, and it's a successful reclosing. The fault stay after the reclosing. First, here we have the currents on condition the substation 1 and substation 2, and then we have the signals of binaries. Here the trip with the substation 1 and the trip with substation 2. And then we have the reclosing command. And then it's another trip with a trip, a differential, and the SOTF. Here we have a sheet that comparing the times in milliseconds. We can focus here on the trip time with substation 1 and substation 2. The average condition, it's about 14 milliseconds and 13 milliseconds. It's different, less than a half millisecond. And then in blue we have the analog hardwire, and in pink we have the process bus environment, the environment of i6-2850. And then in substation 2 we have 14 and 13. It's less 1 millisecond. It's very, very little different between the environment of process bus and analog. The test setup that was used, it's a conventional system. This is an image of the test setup, and that one without the cables, just with messages on the network. Our conclusion was done 520 contingent scenarios, half of this with hardwire and the other half with i6-2850. That was a minimal variation of trip time between the two methodologies. The sample value is slightly faster. We saw about 1 millisecond. The test tool was demonstrated is performed a very good job. It was done in a closed loop. It's a portable solution that can be used in the field. And it's an economical solution compared with the commercial real-time simulators. Thank you very much for your attention.